Okay, so as a quick introduction, we're talking about AI, and usual structure is first I'll talk about theory of something that's new, some questions that came up on our last session, and then practically some of my projects where I show what did the work, but what didn't work. So all theory is wonderful, and it promises that AI will be extremely smart and understand things, and then it turns out not quite. So I'll share those disillusions also. Okay, so that is the today, January 26th. Going down, you can find all that we spoke about, and quite often I find that yes, there was like, what did Microsoft do in this area? So you just go to this and find what did Microsoft, where is it mentioned? So previous links are sometimes useful. But today we're concentrating on exactly what's today, and that is, doesn't want to scroll. Okay, here. So let's talk about different vector DBs. That's the question that came up, meaning this. We discussed how usually today you build your AI applications. And let's repeat that. Here were the slides. Oh, sorry, why does it jump down? I don't know. Here you are. Okay, so just before we had those slides, there. So let's go back to the slides to remind ourselves of what the architecture is. The architecture is called RAG, and I believe that is pretty much the standard. Wherever you go, whatever you see being offered as a course or promoted as an architecture, that seems to be, and you guys correct me, but that seems to be pretty much the standard today. So let's quickly look at it, maybe spend a couple of minutes. What it is. RAG is a retrieval augmented generation. Right, a pretty bad term, not descriptive. What it means is that if you have a question, and that question is not something that ChatGPT can answer right away. For example, you need the documents. You need to supply it a lot of documents, much more than it can easily take, even though today you have a capability to put in your documents and it will digest some of your documents, but the magic stays within the walls. It will only look at a few documents. All right. So if that's your problem today, then comes in what's called the RAG architecture. And that's the idea. First, you store it in a database. You take all of your documents, and store them in a database. Now, it's easier said than done because, first of all, you break all your documents into paragraphs. If your documents are too large, it does not help, and you cannot send too much to ChatGPT, besides you will confuse it. So you need to find only the relevant pieces of the document. That is described here. How do you find the relevant pieces of the documents? It's through embeddings. Embeddings, it's another bad term because it doesn't tell you what it means. But what it means is that let's take these were the documents. Let's convert them to vectors, pretty long vectors, almost 2,000 elements per vector, and that should reflect the meaning. So in the ideal world, you describe your architecture like this. You store the documents, you assign meaning to them, and you call that embeddings. And then when somebody asks a question, you take those that are relevant, that are about your question, meaning, and supply this to ChatGPT. I'm saying ChatGPT, it could be any LLM. People prefer to be generic, but practically all courses use ChatGPT anyway. Okay, so that bunch of slides described how that works and why it doesn't quite work. So that was done by Chroma, and at this time I didn't realize that Chroma is another database, another vector database or database to search by meaning. Now I do realize that's why they put out this course. And they talk about additions. For example, if you ask ChatGPT not just your question, but also somehow procure a possible answer, and then send all of that. You send the question and the possible answer, and search the vector DB for that. Then supposedly you'll come more focused. All right, and then they also described a couple more approaches, like you ask the question, you get the answers. Now, you ask the question, not ChatGPT, you search in your vector database. And what comes back is a list of relevant documents. You resort them, re-rank them. And that was the idea. So let's go back. Here we are. And we wanted to look at other vector databases. For example, Chroma is one of them. Well, that is what I wanted to do. So I went through try Chroma. Let's look at this link. Okay. In this picture, they show you what exactly the search by meaning, what does it mean? But we're more interested in what it is as a product. Well, that's the answer. You do pip install Chroma DB, and then it's yours. So I'm using Pincecone right now, and Pincecone comes with the virtual machine for which you pay $70 or about $70 a month. So it looks like a maybe 4 gigabyte or 8 gigabyte virtual machine on the cloud. That would allow you to be local. That would be, I think, the major difference. Will it work somewhat differently? I would assume at first glance, no, it will work the same, because what's inside is a well-known algorithm of search by meaning. We'll be back to that algorithm, but for now we're looking at Chroma DB, and we see that this is an alternative that can run for you locally. Not only locally, they also offer you to run it for you in the cloud. So that is the Chroma. Now, the other one is a Singlestore. So let's go and look at the Singlestore. Now, what you see here is a Singlestore is more financed. You look at the website, you understand that there's more money there. And they have multiple products, and they have multiple solutions. So obviously, there are more people working on that. And their major offering is in the cloud. Pretty expensive, because 80 cents an hour is what? $20 a day, and it's I can't believe $600 a month. But in any case, you see that you have choice of clouds. Oh, there is self-managed, but still pricey. Okay, so I think the major offering here is enterprise level, expensive, but supposedly working well. That's another database, another vector search. Architecture stays the same. And finally, there is an overview on all of them. Okay, so in that overview, you see how you group them. So if you were using, like you were using just one specific DB, like Pincecone in my case, because I happened to start with that. Well, so you get more comfortable. You know there are choices, there are alternatives. In every case, this is Thomas Micallef invention from 2013, so it's not very smart. I'm coming to the next part of the discussion, but at least that we got all choices for vector DBs. Okay, so that's what I promised, to look at different databases. And one of a particular interest to me is Pinecone serverless. So again, to put it all in perspective, Pinecone is one of the vector DBs, pretty popular in the AI world. And serverless is the new offering. So instead of paying about $100, really 70 per month for each one index, in my case, one company, one application is one index. So it's not too much, not terrible. But if you're not really using it, then you're essentially running a virtual machine for just burning money. So they followed the obvious idea that let's make it serverless, just like don't run a virtual machine for any need and then another virtual machine for anything else. Well, put it into serverless. Serverless means that there is a pool somewhere, pool of service, and you are only charged when you are using one of those machines. So therefore, it can be much cheaper, 50 times cheaper, maybe, and maybe infinitely cheaper if you don't even run it. And my experience doing those serverless things, that they are much more complex to develop. It's just the way you put it into the serverless, package it into container, and then things don't work because it's a new architecture. And I'm grateful to the guys who did it. So they did it as a serverless. Practically, that's very easy. Now that they have done it, let's go to Pinecone. And I'll show you how we do. So you log into Pinecone. And there you have multiple indices. Now I have a few 1, 2, 3 projects. So I only have indices of interest here in the KCPI. And this one, production, we use an virtual machine. It's in US West GCP, just because you can choose which one to use and how much you will pay. The difference is minor 10-15% on price. So invisibly, it works with GCP, even though the system, our system itself is in Amazon. So no problem. It's just a service from your point of view, but the service runs on a particular virtual machine. Now this one, which we deployed in the government cloud. So it is Gov Cloud because there is a requirement, and some offices need to run KCFI Gov. That's what we called it, but it's really called government cloud on Amazon. So we decided to try this, and you see that here. That is running on, where do we see it? It's running on Amazon for a change, and it's running on serverless. Now, I don't quite see where it says that it's running on serverless. Oh, here it says you have $100 serverless credits, but we're almost not using it because the people who wanted it only starting. So it says that the vector counts that you have there is 516. So they loaded very, very little. And practically what I want to show to you is that running it in serverless is just as easy as running it in any other way. And the proof is here. If I create a new index, then I have a choice. Do I want it serverless or on a pod or a free version? There's a start of free version. And then in that case, I don't think you even choose a provider. It's always Amazon, always here. But for others, you can choose which cloud you want and other capabilities. So that this one here, just came up, so they don't give you all the choices, but it looks like no-brainer. You would probably want to do the next one serverless. Now that estimated cost tells you how many records you will have and vector dimensions, writes per month. And if you use these per month, these many writes and this many reads, then your bill is $2 per month and not 70 per month. So of course, very attractive. All right. That is because we were investigating Pinecone in a little detail. So if you wanted to turn and go and use any other database, well, this Pinecone serverless pretty much kills your ideas because look, it's so easy, so cheap. So why don't I stay with Pinecone, but only switch it to serverless? And the practical considerations is when you want to save money, that's when your load is big, all of that will come later. So that's all I wanted to tell you about these databases. Let's see, somebody says something. Pinecone, Paul says, Pinecone has a serverless option in AWS, incrementally very cheap. That's what Paul heard. And I'm very happy that that agrees with what we see, right? So right now we're running it, as you saw, the cloud deployment, but not much use, but I'm sure we'll be switching. The switch is very easy too. Now, when you switch, you lose your current database, but anyway, you usually refresh it very many times. So switching is not a problem for that. Thank you. And I see that you can chime in and your opinions are here in the chat, so I'm not stopping for now. Later on, I'll stop to get your feedback. Okay, the next thing that I want to talk about is the Circle CI. Circle CI is another course from Andrew Ng. Well, Andrew Ng and Circle CI. And it just came out a few days. So I thought it will be interesting to try because, or to see what it is, because that's the whole purpose of this webinar. I don't just talk about news, I try them. All right, so I need to reshare. I stop share, I share again, and now I share with the sound. That's because there will be a beginning of the talk, so let's go there. Now it comes from Deep Learning AI, that's Andrew Ng's company, and it seems like many people want to cooperate and work with Andrew. That is the CEO of this Circle CI. And Circle CI means it's continuous integration. That's what CI stands for. But what are we continuously integrating? That's our AI, our LLMs. Okay, so let us start. The way to get to it is just click and all the links are there. We'll start in a second, but that's the way to get to it. All these courses are right now free. And some people who don't like free and they feel they will be better quality if they pay, well, it's somehow different now, different world. The knowledge is abundant and it's free. Okay, so what are they talking about? They are talking, well, let them talk.
Welcome to this short course, Automated Testing for LLM Ops, built in partnership with Circle CI. Software testing helps you identify bugs and security vulnerabilities in your applications, and automated testing frees up your time and energy further so you can focus on the creative parts of designing and building your application. In this course, you learn modern software engineering practices focused on testing for the practical development and deployment of LLM-based applications. Two kinds of LLM evaluations that you implement in this course are rule-based evaluations and model-graded evaluations.
Okay, so let me describe briefly what it is. First of all, they give you the notebooks. So let's say you start a lecture, just start a little bit, and then you can stop it, and then the notebook shows up. So you can copy paste and make sure it works for you on your machine in your repository. You can run it here. I think if I run it here, it will run. And it's guaranteed to run on their machine and in their environment. But on yours, usually I have to play like half an hour to an hour to set everything exactly as they do. One trick that I use is if I add another cell here, another code cell, and I need some files that they don't give you. They read some local files. So you do exclamation point ls, run that, and then you see all the accompanying files in that directory. So if you need the configuration, which is not shown anywhere here on the left, you do ls, and after that, you have many ways to bring it down. I don't remember what exactly I used, but it's very easy to do it. So that is number one, advice number one. And advice number two is you can file and then save as, no, not save as, so download as, and you can have all the formats. The one that you really want is IPYNB, this one, notebook, okay? So that's the easiest way. Instead of copy pasting, you can download the whole thing. What they give you, and that's very nice, are two ways of approaching it. First of all, you want to run your LLMs. When you have a very structured way, for example, you want to do sentence analysis, something that used a lot of work, train your model, all of that, but now you ask ChatGPT and it tells you. But in your particular situation, it might not exactly work the way you want it. You might want to try it with a different data set. So they offer you the first approach called rule-based. What they mean is regular expressions, regex. They run their evaluation multiple times. I would imagine hundreds and thousands of times. They also CI, continuous integration, they automate, and they just watch that their quality doesn't go down. All right, I was just reading a blog post where somebody was saying, oh, I'm showing you a new great model, and that model always improves, as opposed to ChatGPT itself, which sometimes goes worse. Well, if he is right, that is strange. Don't they use that? So that means that the problem is not as easily solved. But at least you would want to test your model if it is somewhere in deployment, like many models are. Then you want to keep an eye on quality, and that's the first way. To automatically test it using regular expressions. But that is nothing revolutionary, even though you would want their help, you would want their code, it will help you. But it only goes so far, and that's only if it's structured. What if you are doing estimation of how well it summarizes books? I remember that Greg, the CEO of OpenAI, he said, well, summarization is a big problem, and who wants to read the book? Well, there you are. He revealed himself as somebody who doesn't want to read a book, but it really is sometimes a must to summarize books, especially if they're technical nature. You know, the snobs will say, don't summarize the Iliad, it won't be fun. But in practical applications, it is good, but regular expressions don't help. So the major idea in that case is bring up another model. Bring another model and test your model first, and then run it against the second one and ask it, well, how good the first model behaved? How did it perform? That sounds very good, and it is indeed working. That's more extensive, probably more expensive also, but that's what they do. here they give you the notebooks, and they also give you good advice on what to say to the model. I don't remember all advice, but you can tell the model, be brief, or imagine that you are not that smart. You can give it any instruction, and the longer you give it, the better. And in fact, they give you.
So far, you've used
very long instructions. That's automated model graded at Elfstone. They give you the instructions that you should send to the grading model. And they are very long. Now, I thought that very long is not a problem anymore because there is a new model out. So where do I find this model? It's hard for me to find the link right now, but if you go into all the models of ChatGPT, you see the new models, which they say don't put them in productions, but it is much more, the limit is much higher. With the current GPT-4, I think you can send 8,000 tokens. With some kind of modification of your plan, twice that, but the newest model is 100,000 tokens. Well, any kind of model question, any kind of instructions will be fitting. With the latest model, and I'm happy about this. Here's the problem that I had with GPT-4, being that 8,000 is a limit. Practical application of RAG looks like this. You go find all or a few of the related documents, and you miss. There are more documents than you can process, but you don't realize it, and it refuses to answer because there are only 8,000 tokens you can send, and you get very inconsistent behavior. Sometimes the AI says, I don't know, and sometimes says, oh, that's easy, and gives you the answer. But I switch to the new model. I can send up to 100,000 and no problem. It's always stable. So that is practical and nice, but I'll tell you about the real problems later on. And there we will see that we're dealing with magic. We're dealing with the apprentice, wizard's apprentice, I think. There's a music piece. So it's capricious. It doesn't always do what you want. Now, let me look into what you guys say. I see on chat. Okay, that is something about Jianshi, about the way we send you the theme. So what I will do, it's very important, it should work. So I will put it in Slack and I send it to the organizer. And on the webinar. There. Okay. So that we will work. I wanted to stop share and give you a chance to say, talk, do something before I go to the practical aspects. Okay, thank you. Let us share again. Here you are. And we looked over that. Let's go back to our plan. And the plan was to look at different databases, vector DBs, to look for meaning and look at how you can automate quality control in your LLM. But practically. So we already mentioned that that RAG is not perfect. However, it's really not perfect. That's because I mentioned a few times that the very first step in RAG is find me the relevant pieces. we assume that it finds the relevant pieces, right? And then only give it to ChatGPT. But the problem is that the way you look for relevant pieces is 10 years old technology. There's nothing wrong with being 10 years old, but ChatGPT is so much stronger. The end result is that your search for relevant information is very primitive compared to ChatGPT, and I really wish I had the whole ChatGPT and the capability to do that. Then probably I could solve my problems. But now I'm using the regular RAG. Now, in these slides that I showed you, they give you a couple options. One option is ask the question and also provide the possible answer, then go to the RAG. That's one way. And then another way is to re-rank the answer of that. And I think the third way is do a little training. But what if you never get the relevant documents correctly at all, which is quite possible? I'll show you how that happens. So that's one of the projects I'm working on. That's a virtual machine. All right, that's what's going on inside, and that's where it says, I don't know, because I'm asking it for some very specific something. So the guy I'm working with, he tells me the answer is that it should know the answer is in document 116. That's my internal lab, but this is the outside view of that same lab right here. Okay, and the cases that I have are 3, and I'm only interested in this one where I loaded 37 documents, 37 instructions for what to do, and then I'm trying to search. And when I'm searching, I'm asking a question. And that's a search. The document is there. That's the document 116. It's the most relevant that came back. The rest are not relevant. So if now I ask the question, very specific question that only a specialist could know. So I don't understand. So he says, I don't know. But please look at that. These are the links that show you the exact document where that answer should be located. Let's open. Here's the document. I can see that. It's right here. That's my text. But look here. The document 116 is not even mentioned. Now, that number is not the real number of the document, but I can show you where all the real documents are. Okay. So that's the real number. And the document number 116, I already showed you. So bear with me, please. I didn't spell it right, and it doesn't get it because that's not AI. But in any case, the first step, the very first step of your RAG, if it doesn't really even find the right pieces, which is quite possible. Here, I wanted to show you exactly that it doesn't find them, but you can agree with me that being that it is quite an old technology trying to look for meaning, when the meaning itself was not very well defined and using word to back, that's what they use, you didn't get very precise results. So that's where the algorithm breaks completely. The reason I showed you that is because it shows all the documents here that it considers as possibly relevant. And the real one is not there. So the question is not why AI didn't get it. The question is why you didn't supply to the AI the real document. All right. You know, in Solvello, there is a phrase where he has a theory about why the bandits in Chicago destroyed his car. And he says, that morning I was wiped out as urban psychologist. Well, that evening I was wiped out as an AI expert. It just doesn't work. However, I have a plan. I just haven't done it. That I will probably show you by next week. My plan is this. First, let's do the search. Didn't I myself find that search works? Well, the first part of my step is do the search. But wait, you will tell me, search. So who needs you or search? It's a very, very well-known technology. No, I'm a bit smarter than that. When I'm asking, tell me please, that's AI, right? Now, right, so it will tell me I don't know. Right. Okay, but what the important words are here are those and integrament. These are real professional terms. So my first step will be to ask ChatGPT, which are the professional terms in the next phrase. There you are. It tells me the terms you're looking at are only one. So I'm going to ChatGPT to ask, tell me about this query. How should I understand it? Then I'm going to VectorDB to look for this. No, not to VectorDB as yet, to search. With the search, I get the right documents. With this, I'm going to VectorDB, and with this, I'm going to ChatGPT. And if you tell me that it's kind of too slow, isn't it? Then I will ask you, but look, sometimes it is also very slow. And typically a few seconds, but if you're going for specialized things like this one, right, and then it will first say, no, that was easy. But very often it first hesitates, shows you pictures, distracts you. No, no. Oh. And it should say, I'm studying my documentation. So it seems like some easy things it gets right away, but more complicated it thinks. Misspellings are okay. It gets it, it's cardiologist, but it often thinks. So what I'm saying is that the fact that the answer comes after a long time, well, you show pictures, you show some dialogue, some things you know pretty fast. But after that, you make a more complicated search. You first ask the model what's important, then you search for that important, then you come back and you do the RAG. Will it work or no? That we will see later. But what I'm showing you is actually a better and better looking lab or how would I say it? It's a self-contained discovery machine. Because right now you have the search, you have the AI advisor, you can see your cases. And one thing that is missing right now is here, load my data. When I do this, because right now to load your data, you'll need to ask me, Mark, can you give me this interface? And I don't want to give you this interface because I trust you guys, but a regular user will take my key and run with it. So the key will stay inside. They will only see that. And with that, they are missing one capability to load data and start processing. So that's what I just implemented. Now we need the UI part to load the data, and that's all will come to us next time. So let me do this. Here we are. I promised the theory about databases. We looked at them. We looked at the latest offering as serverless. And we looked at the new course where you can learn how to continuously test your models. And finally, these are the practical problems that I am dealing with and the possible solutions for them. And by the way, Read is almost ready to be released. That is all the news that I wanted to talk about. So I am doing stop share. I'm going to the list of participants. Thank you all guys for attending. And I'm giving you a chance to talk, introduce yourself, ask a question. That's the whole purpose of collecting together so that new ideas will fly. Awesome. So I see on the chat, Paul is giving us a readathon.
Hi.
So it's
There's a hackathon coming up, and it's free. And it's sponsored by, I guess, DataStax, and it's run by Llama Index, I guess a company maybe commercializing Llama Index. And it could be interesting.
Yeah, it would be. So let me share again, and let me click on that so that everybody sees that. Oh, meanwhile, I lost the chat. Here is the chat, and there you are. Right. So you're saying it already was or going on right now? February, it's coming up.
Yeah, it's coming up. It's pretty soon. It's like in a week.
Yeah, I think that's interesting for the people. I'll put it on our running summary, because at least people, when they come and look at it here.
And they talk about AI agents there, but I'm not sure how you turn RAG into agents.
Yes, but they talk about this, right? So let's do this.
Yeah.
And now let's
that notification did say it's in person, so I'm not. Where is it? It says
Oh.
DataStax HQ.
It says in Santa Clara.
Oh,
Yeah.
Santa Clara.
Yeah, if you're remote, you could work with somebody local. It's actually okay to do that, by the way.
Okay.
Oh, okay.
I'm not sure how you find a team doing that with. Do they have a team finder? So I'm wondering whether one could sign up and claim local, but actually find somebody, to work with remote and be remote and have somebody who's local.
Yeah, they said that they've got. You need to have at least one person there local. So
yeah, right. Yeah, but if you find a team, then you could find somebody like
right.
that.
But you know, I was at DataStax. It's a lovely place, and well, it's a good place to be, right? So it's a nice thing. Okay, you'll decide.
By the way, I'm signed up and I'm still looking for team members.
Ah, but you will be there?
Yeah, I'm local.
That you didn't tell us, right? So
Yes.
that's good. I'm not writing it in here, but those who heard.
Yeah. Right.
So you have a
Or maybe even put
contact?
it in there, Paul. What if I say, get in touch with Paul? Okay,
Do we
awesome.
just message you through Meetup?
Yeah, that
Paul?
means you agree by giving me your
just put my email address there if you want to get in
There
touch
you
with
are,
me.
right?
We can see if something can work out.
Oh, wonderful. Okay, and then there was another question. Does the size of the chunk of the document affect the reg performance? That is the greatest possible question, because yes, it does, and not only that. First of all, when you take a document and send it to this database, for example, I use LangChain. LangChain includes the algorithm of dividing the document into chunks. And it includes a choice of algorithms. That's number one. It's kind of, there's a lever there to adjust things. But I had a situation where I had to make them somewhat bigger. And that situation was in case of my Talmud Illuminated. That's my first project. That's my personal like. And here, each piece of knowledge comes to you as potentially 3 paragraphs, right? But it really is carefully written by me, and that's a single piece of knowledge. So in this case, I don't break it. Not only because of the size, but because of the meaning, okay? Even though it is a new line every time, but I'm sure that there are other there are other situations where you have 2 lines, and I think that also depends upon the size. It doesn't matter. Your question, does it affect the performance? Not only it affects performance, it is an important choice of the designer, exactly how you break them into the documents. Like in my case, the one that I shared with you, the integral link case, it couldn't even find it at all. Okay, and I'm going to try to do search first. Well, ask ChatGPT first, then search, then ask again. It's a complicated thing. Okay, now social says the webinar is detailed. I'm amazed, but if I can request any suggestion how to better use this webinar, I could relate and understand the stuff, but not sure how to use. Let me read. How to improve my learning. Okay, so for that social, you come here and you are here and ask exactly your question. And the answer will be that you go to this page. That page everybody has. Just in case, I'm giving that page to you again. There. Now, in that, you have a webinar folder and learning path. So you go to learning path. That's open. Okay, wonderful. Thank you very much for showing this thumbs up. And that's where all the learning happens. So you start from the very first one. Generative AI for everyone. It's the longest of them, but it's only because you are going with your leisure and no rush. You can do it in a day or two, even though officially it's 5. And then you look at ChatGPT prompt engineering for developers. That together gives you the knowledge that you need to continue. After that, you will not need me, or you can still ask advice, but you can go to more courses. They will go into different areas. That is where you start. And then you will gradually catch up. All right. Now, Elmer Cut, how many characters is best for chunks? Again, the length chain algorithm by default does paragraph after paragraph. So how many paragraphs will be, how many characters in the paragraph? Well, that depends. But in our practical situation in Casey5, we had to add additional breaking because some of the court documents were not breaking into paragraphs at all. So that means that there is no good guidelines on how many characters. You try to use primitive division by paragraph, but if some paragraphs come out too big, you adjust that, and then you begin to analyze the meaning of them. And sometimes you either break them up or you glue them together. I think the last thing that I will show you is that I have an additional project, which I maybe even showed last time. And that is where we're taking a book on gas chromatography, which would have two problems. The paragraphs are too long, and this is too complex. So, and besides, there might be copyright, which is only coming up in courts, and I don't want to be on the hook for that. So therefore, here you are. We have a blog summary of each of the chapter. So because I did the same approach with the Talmud and that worked, when I summarized it on the blog, the result is the answers are better than just general ChatGPT. So my hope is that, and I see there's much more. Adrian, my friend, is working on that, okay? So great. So that's enough to put it into the framework, to crawl the blog, to put it into the Pincecone, and then to see if that is a smart approach or no. That breaks each piece of knowledge into a reasonable size. So I'm going to use exactly that. The size of the blog digested for ChatGPT might be exactly what you're looking for. So that is, to me, the best answer to your question. That means you need to prepare the knowledge. Of course, people may ask, well, if you prepare your knowledge, isn't that too much work? Yes, but I'm teaching ChatGPT some very specialized knowledge. Maybe that's the only way. So that is all in the area of real research, needs further research. Okay, I hope I was asking you a question. It seems like you're saying yes. That was at least what we're talking about. All right. So I really enjoyed your reactions and our discussion. Thank you very much. We'll be back next week, and you will get a recording of this one, and you will also get a plan of what we'll be discussing next time. So everybody have a good week, good weekend, and a good week, and a good year.
All right, thank you.
Very welcome.
Very informative. Thanks.
Thank you, Jonathan. Thank you, everybody. Thank you, Brian.